Greetings, chemistry students. In this video, I'm going to show you how to work the ideal gas law problems worksheet. And just keep in mind that the ideal gas law itself says that PV equals nRT. That's found on page 3 of your reference tables. So in problem number 1, we're trying to find volume. So if we rearrange this equation that we've got, volume equals nRT over P. So we just plug in the numbers. N is moles, which is 0.02 moles. Then we need the gas constant. And since our pressure is given to us in kilopascals, we need the gas constant in kilopascals, which is on page 1 of your reference tables, which is 8.314 liters kilopascals per mole Kelvin. And then we need our temperature, and our temperature must be in kelvins. So we need to add 273 to our 27 degrees Celsius. And when you do that, that's 300 kelvins. And then we're going to divide that by our pressure, which is 0.505 kilopascals. And then we just take our trusty calculator and we get 98.7 liters, or 98.8, depending on how you round there. This second problem is actually not an ideal gas problem. A big hint to that is there's nothing about moles, and it's talking entirely about partial pressures. So this is a Dalton's law problem, which says the total pressure equals the individual partial pressures added together. So the total pressure 12 equals the pressure of hydrogen, which is 5 atmospheres, plus the pressure of helium. And so the partial pressure of helium is whatever adds with 5 to equal 12, which is 7 atmospheres. That's a really simple problem. Now back to the tough stuff. In number 3, it's asking us to find moles given a pressure, a volume, and a temperature. So if we rearrange the equation that we have up at the top, we get that moles equals PV over RT. So if we plug in, our pressure is 89 millimeters of mercury times a volume of 6 liters. Then we need the gas constant in millimeters of mercury, which if you check your reference tables is 62.4 liters millimeters of mercury per mole Kelvin. And then we need our temperature. So we take 65 plus 273, which is 338 kelvins. So we're just going to multiply all this out. Don't forget, when you put it in your calculator, you need to put parentheses around what's on the bottom, unless you've got one of those really fancy calculators. And the answer is 0.025 moles. Problem number 4 is asking us to find pressure given moles, volume, and temperature. So pressure equals nRT over V. So we have 15 moles. Our gas constant, it wants it in kilopascals, so we're going to use the 8.314. Our temperature, 20 degrees Celsius, is 293 kelvins. And our volume is 75 liters. So we plug all this into our calculator, and we get 487 kilopascals. And then problem number 5, it's wanting temperature. So temperature equals PV over nR. So our pressure is 0.053 atmospheres. Our volume is 2.5 liters. Our moles is 0.43 moles. And the gas constant in atmospheres is 0.0821 liter atmospheres per mole Kelvin. So we put this in our calculator, and I'm coming up with Now, in this equation, our temperature comes out to be in kelvins. problem asks us for Celsius. So to convert to Celsius, we need to subtract 273. And when we do that, we get negative 269 degrees Celsius. And that's how you do the worksheet.